Well, hello out there. And if you're not subscribed, please consider doing so. And also a particular thank you to my members as well. Link in the description. So we've got a Kangoo here, something a little bit different. It's not a ZE. Okay, cool. So 19 plate Renault Kangoo. This is a 33 kilowatt hour, range of about over 100 miles. Quite cool. It's actually a fridge van, and the refrigeration unit doesn't fit in my workshop, so that's out there. But yeah, quite cool vans. This one doesn't charge, okay? So customer's not actually had it that long, I believe. But yeah, it trips the mains when you plug it in. A very similar architecture to a ZE, but a little bit different, and we'll get into that in a minute. So it's been to Renault, as most vehicles have. And Renault Diagnostics vehicle is not charging at all. When he tries to charge his vehicle, it keeps on tripping out. Carried out diagnostic confirmed fault code for battery charge circuit. It requires a new onboard charging unit as it has an internal fault. And a free vehicle health check. Wonderful, that's what everybody needs. So I should say thank you to Sebastian for sending me this. Come from London out to me. And Renault will just, a bargain to repair this vehicle would be sum total of £6,488 and 10p, which weirdly was declined. So £6,500, which basically is the value of this vehicle. How did they get to £6,500? So these onboard chargers are actually available for this car. So if you know a little bit about ZEs, you'll know that charging is really complex, and it uses like the motor windings and various components, and there's a rectifier, and it's all quite complicated, a charging filter. The architecture of these is a lot simpler, basically. So it's got basically what's pretty much a ZE motor, a little bit different, and a very similar reduction gearbox. It's got the same sort of control box, but it's not got the charging filter on this side. What a Kangoo has got is basically a bog standard onboard charger that you would have in any EV that's not a ZE, basically. So it just takes mains. And you can see on the socket actually that the bottom pins are not populated, so this is single phase charging only. So we've just got live earth and neutral across the middle there, comms pins at the top, and they literally connect to this onboard charger, and you get DC out the other side of it. And that's it basically. So really simple charging architecture. It's right there on the top, which is nice, so we don't have to take the whole stack out like we do on a ZE to do anything basically. But Renault want to charge £6,500 to fix this van. So I've asked the Renault parts desk, who I talk to quite a lot, funnily enough, if they can get one of these, and yeah, they can. And it's about £2,500, I think, something like that. So it's like, how did they get to £6,500? It's reasonably accessible. The only thing I can think, well, there's sort of two options as to why they said £6,500. One is that's roughly the value of this vehicle, and they just don't want to do the work because they're not confident, so they just kind of picked a number which they knew the customer wouldn't go ahead with. Or the other thing is that their EV technician has worked on a few ZEs and they look a bit like this. And with a ZE, when you have an issue like this, you replace basically the whole control box, which on a ZE is this side, so it's like this, but this bit as well, and it's all combined, and it's loads of work. So I kind of think that maybe they're thinking a ZE type repair because it's got a ZE type drivetrain. That's the only other thing I can think of, because even at Renault labour rates and Renault prices for new parts and everything, I really struggle to see how you get £6,500. But anyway, it's going to be a lot less than that. So what we need to do is, well, the first thing we're going to do is do an installation test on this onboard charger. So I wouldn't just plug it in straight away because the customer says it's tripping the mains. We do some tests first and we work out what's going on. So I've got my installation tester. So a normal multimeter, when you do a resistance test, it's just a really tiny little voltage and it just checks the resistance between 2 points. That's not really suitable when you're working with something that's mains or with high voltage DC. What this machine will do, it's similar to a Mega. It basically generates voltage. We can actually give you a demonstration. One moment. So this will actually generate a voltage that you select, and then it will detect the presence of that voltage. So it's kind of mimicking the system when it's running, because obviously when this is working, there's mains voltage going in here. You know, when these cables, when the vehicle's on, there's up to 400 volts DC in here. So you've got to test it kind of similarly. So we can choose what voltage we want, and we can change that as well. And yeah, we can kind of make it generate what we want. We can do all kind of cool stuff, basically. So yeah, what I'm gonna just do is, so that's set to 500 volts, just to prove how this works, so that you know I'm telling the truth. If I connect this to my meter, which is slightly hard to do with one hand, yeah, and press this measure button. Let's do that so you can see both of them. Right. So you can see that's generating 516 volts, and then we let go of that, and it goes back down again. And now we've got what's called like a ghost voltage. We've got minus 500 millivolts. But yeah, and apparently my meter has got good internal resistance, which is good to know. But yeah, so this meter actually mimics what's happening when you actually plug it in, which is cool. So we can use that to do a kind of accurate test. So what I'm going to do is I'm going to clip this onto a suitable earth point. So let's go on that little, that is a coolant bleed location. I'm going to go onto here. So these have got a plastic cap on. The earth doesn't have a plastic cap, but that one you can see there, that's live. Put that on there, so that should be past the plastic cap. Right. So my meter was 9.95. Basically anything below 5 is poor, and if it's really low, then really poor. So we've got a 0.07, and if you're watching down in this corner, so this meter is generating high voltage but really low current, so it's milliamps, and the milliamps weren't enough to get the voltage up. Basically the meter couldn't sustain the voltage because the current was leaking so much. 0.07 is basically a dead short. I'm going to repeat it on the neutral. Yeah, 0.03. So this onboard charger has a dead short to earth inside it. So what I can actually do is I've got another Kangoo outside. So I'm just going to repeat this test on that Kangoo out there, which doesn't have a charging fault. And we'll see what happens in one moment, please. Okay, so hopefully we've got another Kangoo. This one's got air conditioning. Oh yeah. Yeah, I should have said I've removed the fan housing from the other one. With that on there, it really makes it look like a Zoe under here. So yeah, I've got the connectors in the same place. I've got one on that pipe, and I've got one on that side there. Set this, and let's give it a go. Yeah, so we've got 500 meg, which is like a perfect result. Swap that to the other side. 500, and if you saw there, this meter was able to sustain the 500 volts that we asked for. So because there's no leakage, that really small amount of current basically isn't just bleeding straight to this other terminal, basically bleeding to earth. So we'll pop back to the other van and we'll work out what we're going to do next. Cool. Okay, so what are we going to do next? So kind of as I was saying earlier, this onboard charger is quite accessible. It is water cooled, I think. There is a pipe under there, so maybe it's full of coolant. Interesting. Yeah, so basically we need to just start stripping this down, get this charger off, get the lid off, and have a look inside. Basically see what's happened, see if it's repairable, see if we can run some tests. Yeah, I don't know what we're going to find, but yeah, I've also had a look, and there are some used ones available. And it's not a very common failure, so a used one's certainly an option. That would definitely keep it under £6,500. Yeah, so, but I'm quite keen to see what's sort of going on inside this one, and then we can decide what we're going to do. Give the customer some options. All right, cool. I'm going to get this off, get it on the bench, and then we can see what's going on. Yeah, all right. Cheers. Okay, so we've got the onboard charger off. That's there. I'm going to do a test on that in a second just to confirm that's definitely the faulty component. Once I'd disconnected the cables, I ran the same test again through this socket and got a good result. So we know it's not the cable. So the charging cable basically runs around here and connects to here. And then on the front of the onboard charger there's battery connection to the battery as well, to the DC system, and a comms cable as well for control. It's quite an interesting design. So it is water cooled. I thought it was because we saw these pipes, but then I realised they were connected to something below. It's actually connected to the tray that it sits on, and then it's bolted down, and these actually pump coolant through it. So kind of, yeah, a bit of a weird design. I don't know why they didn't just put those terminals on the onboard charger. Kind of odd, but yeah, maybe they wanted to sort of keep separation between the potential coolant and the sort of cables. Yeah, not really sure, but yeah, an interesting design. Just trying to make sure everything stays dry down here, because there's always a bit of coolant loss. But yeah, just before I plug that up, I just thought I'd show you that. So let's do the test again on the onboard charger itself, because before we take this apart, we want to confirm that this is definitely faulty. So we stick this on our, get the grub off it, stick this on the case. This one is the incoming AC, and we run the test. Yep, that's a dead short. Do the other one just for good measure. Obviously, it goes without saying I have done high voltage isolation on the van and all that kind of stuff, so we're working safely. So we've actually got good on the DC side, so that explains why the van was still able to run happily, because if it had a dead short on the DC side, things are not going to go well. So yeah, we've got a perfect result on the DC side, where the charger connects to the vehicle's DC bus, whatever you want to call it, to feed that power in. So the AC comes in here from the mains, gets rectified, and then DC comes out of here to charge battery. Yeah, so on the DC side, we've got a perfect result. On the AC side, we've got a dead short. So it's definitely a fault inside this unit. So the next thing to do is take the lid off and see if we can see anything interesting. All right, let's do that. Well, I think we've found the problem. So the lid has got a little bit of charring, and I think there's been a slight, what we would call, thermal event. Yeah, oh sorry, I was moving the camera, I was actually looking with my eyes. Yeah, it's a shame that smell-o-vision hasn't really taken off, because it doesn't smell very good. Yeah, okay, so yes, a minor thermal event. So we can kind of see, so this is the AC side and this is the DC kind of side. We can kind of see that. You can't, there is a bottom part to this, although it's got that cooling in it, so just trying to work out whether there's like a kind of another layer below it. It's quite possible. I will strip this down a bit further, but yeah, I think we were kind of wondering if we could repair this. I think that's probably not gonna happen. I think yeah, replacement is our only option. So just from a kind of architecture of the onboard chargers before, they're going to be capacitors, because that's the type they use. There's obviously another capacitor there, and I mean, yeah, it's burned, hasn't it? It's not pretty. I think it would take a very good fire investigator to work out exactly what had happened here. It's obviously worse. You can kind of see that it's from this area. It's come sort of, this kind of jarring has bled around a bit, but yeah, obviously something has gone a little bit wrong in this area. Okay, well, at least I can let the customer know realistically we're not going to be able to repair this unit. Yeah, I think, yeah, talk to the customer, see if they want to go with a new one, or which is still not going to be £6,500. Yeah, or if they want to go with a used one. It's not that common a failure, so used one is a reasonable idea. It's going to be a lot cheaper than a new one. But yeah, all right, see what the customer wants to do, and I will catch you in a bit. All right, cheers. Okay, so replacement onboard charger has arrived. So customer wanted to go with a used one, which is fair enough because a new one is quite expensive. And I don't think it's a particularly common issue. So yeah, hopefully a used one will be okay. The old one, actually, I left it in the workshop. And then went and ran a couple of errands, dropped off some parcels, came back to workshop, and absolutely stank of charred electronics. So I had to, had to get the old one out of the workshop because it absolutely stank. But yeah, we're going to get this one fitted and then, see if that works. So yeah, we've got to get this back down, make sure these coolant sort of channels seal. So I need to make sure this one's all clear underneath. And that's going to fit nicely. Yeah. Get this on. I sort of kept an eye on this and it didn't leak, which is good. Everything else is sort of sealed. I thought about plugging up the pipes, but yeah, just because I think, it's kind of the rest of the system sealed, nothing's come out basically. It came pretty quick, this, to be fair. So but yeah, I did kind of like keep this covered, but no coolant leaked, which is good. So I'm going to get this on and just get it loosely fitted, and get the sort of cables on and just check it works. All right, let's do it. Well, it seems to be a bit of thunder and rain, but hopefully you can hear me. So got this charger loosely fitted. I haven't got this bracket on the top, but we just want to check whether this works, and haven't got the motor cooling fan in. There was an earth cable that goes onto that bracket, so from the type 2 sockets I've just bolted it on there, just temporarily really, and bled it out as well with the bleed points. So yeah, I'm just going to plug this in. I've got my granny lead. I'm just going to check if this charges. So we plug it in. So we've got some comms, so let's lock that in. Oh, it's flashing. Oh, that's a good sign. They don't make... Oh, it's pulsing, so that should be a good sign. Let's just have a look at the granny cable. It's obviously not tripped. Oh, and if I move over here, there we go. 2.1 kilowatts, 9.5 hours, so that's cool. This is kind of a bit of a long lead, this, so don't worry about the voltage too much. But yeah, that is pulsing. This is just kind of like a testing, workshop testing, really. I wouldn't leave it on this too long where it's plugged in. And oh, sorry, if I just turn this off. No, you still can't see that because of the light on the camera. There you go, charge remain 15.5 hours. So there you go, it's reasonably low. We are obviously just on the granny cable, but that works. So there we go, that's quite cool. I like that. Yeah, that's good. That's good. Wicked, right. So I'm going to let this charge for a little bit. Then I can obviously put it fully back together. But that one, yeah, that one is done. Another one bites the dust. Cool, I'm going to let that charge for a bit. I will put it on my 7 kilowatt charge point as well. But hopefully that was interesting. Yeah, it is quite an interesting design, these. The most interesting thing is that they've like custom made a drivetrain and made it worse than the Zoe. So the Zoe's, you know, all this sort of, it's this size and shape, but they've changed some of the components and made it worse because it only does the 7 kilowatt charging, which is kind of a bit random, really. I don't know why they didn't just put the complete Zoe drivetrain in the Kangoo. Maybe it's because it hasn't got battery cooling. But then isn't it easier just to put battery cooling in a Kangoo? But then you need air conditioning. So this one hasn't got AC. So not all Kangoos have got AC. Without AC, you can't have battery cooling. Without battery cooling, maybe it's not a good idea to have more than 7 kilowatt onboard chargers. Maybe that's why. Yeah, if anybody knows, then let me know. I do know the first Kangoos, so the early 22 kilowatt ones, only charged at 3.7 kilowatts. Okay, so they were like 16 amp, real slow charging. And that was basically because they were developed for La Poste, and La Poste wouldn't pay to have a faster onboard charger. Basically, it was a 22 kilowatt hour van. It would charge overnight when they plugged it back in at the depot, and they literally weren't willing to pay for anything better. So that's why the early Kangoos charged so slowly, basically, even though they were very similar to the early Zoes. They were a 5 AM type drivetrain. Yeah, but they were just slow charging, and this is kind of the same thing again, really. I guess similarly with those, maybe they didn't all have AC. Interestingly, the other one I've got, which we did the charging testing on, which is that one in front of this, so with a battery fault, that one's actually got air conditioning, which this one hasn't. But yeah, and no Kangoos have battery cooling, and I really hope you can hear what I'm saying over the rain. But yeah, it is all good. Well, I enjoyed this little Kangoo project. I have done Kangoos previously, but nothing particularly exciting on them. But yeah, this is the first sort of onboard charger replacement. So hopefully that was interesting. And yeah, any Kangoo issues, let me know. And I think I'm gonna have to go. So I will catch you later. Cheers.